All right, so this is the difference quotient, and that's what we're learning today. And it has to do with functions and inputting different amounts into functions, inputting different variables and numbers into functions. So this is one of the basic definitions in calculus. When you go to calculus, or maybe at the end of the year in this class, you will use the difference quotient for things. Definitely when you go to calculus. F of x plus h minus f of x, all divided by h, where h cannot equal 0. All right, why can't h equal 0? Undefined, right? All right, so in your assignment, you're going to evaluate the difference quotient with what the information is that they give you. Now, this example, from what I heard, is even like harder than some of the questions in your homework. Just so you know. That's what people were getting confused, like, is it really that easy? And I said, yes. So you really just got to pay attention to what it's asking you to do. This is saying we have a function, f of x equals x squared minus 4x plus 7. What you're going to evaluate is you are going to find that function value when you put in x plus h instead of x. Subtract off putting in x where x is, and then divide that whole thing by h. So we have to take x plus h and put it in for every single x. So that's what f of x plus h means, is replace the x with x plus h. That's what f of x plus h means, to plug in x plus h for all the x's. And then we've got more to it. So I'm going to do just that first part right there where it says f of x plus h. I'm just going to do that part first. So f of x plus h will be, where's my first x? X plus h, x plus h, and then I'm going to square that. So I replace the x with x plus h. Minus 4, I'm replacing the x with x plus h. And then plus 7. So that is the first part. That is the f of x plus h. Then we have a subtraction sign. And then we have a second part that says do f of x. Well, I already know what f of x is. F of x is x squared minus 4x plus 7. Then the third thing is put it all over h. So those are the directions. It's telling me to plug in x plus h, plug in just x, and then put it all over h, where h is not equal to 0. So now we're going to simplify. I went over this in first bell, and a lot of people missed it. So let's get our attention up here for just a moment. When you square a binomial, when you square x plus h, when you multiply x plus h times x plus h, you will get 3 terms. You will not get 2 terms. You will get 3 terms. I can multiply all of that out. Or I might know the shortcut. I know the shortcut. Do you know the shortcut? If you know the shortcut, do your shortcut. If you don't know, I'm about to do it for those of you that don't know it or don't remember the shortcut. If I'm multiplying x plus h, I'm going to move it over here, times x plus h, and then we're going to multiply first is x squared plus xh plus xh plus h squared. So we're foiling that out, and then we combine our like terms. We get x squared plus 2xh plus h squared. So when you square a binomial, the trick is that you square the first term, you square the last term, and then you take 2 times the 2 terms multiplied together for the middle. It's just double the 2 terms multiplied together. So if you know that shortcut, it saves you some time, which is, I will always use that shortcut. Okay, then I need to subtract, and we've got 4x minus 4h plus 7. Now what happens with this subtraction sign? It has to distribute. So just because I put it in parentheses is not the reason why it has to distribute. It's because we're subtracting up here in step 2, we are subtracting that entire f of x. That's why we're distributing. I put them in parentheses so you would know to do it. When you do it on your own, you got to make sure you either put it in parentheses or remember we subtract the whole thing. All right, combine like terms. Looks like I have a minus x squared and a positive x squared. I've got a minus 4x and a positive 4x. I've got a positive 7 and a minus 7. I think I got them all. So I get 2xh plus h squared minus 4h over h. Is that all I can do to simplify it, or is there another step? Go farther? By using what? What, Lainey? So when you say pull out, you mean factor out?
Yeah.
Yes. You can factor out that h. So I'm going to factor that h out. We get 2x plus h minus 4. I don't really have an order that this one would need to necessarily go in. Once I factor out that h, what does it allow me to do? Cancel those h's, right? So now we've got, well, change color, 2x plus h minus 4. Now, do I need to include the domain restriction as part of the answer? Why? Because you have to, right? I can't understand. Who wants to say why? Who knows why? Christopher, you know why? I think I understood what you said. Basically, he's saying that in our final expression, h being 0 doesn't really affect anything, but this is a simplified version of the original expression. In the original expression, if I had a 0 down here, there would be a problem. Okay, and just because we simplified doesn't mean, okay, now x can equal, or h can equal 0. It doesn't change that. It's just you have to put that because looking at this answer, I would have no idea that h could not be 0. So you got to put it there so somebody would know that. Okay? And speaking of domain restrictions, just to go over that concept a second time, I went and I opened up the Algebra 2 book and I grabbed a question that you probably did last year in homework, just to go over the restriction thing again. You won't have any questions like this in your homework, but just to go over the domain restriction. Let's simplify that. It's also a good thing to review. Let's simplify it. What would you have to do first when you simplify anything that looks as fun as that? Gavin, do you have an idea of where you'd start?
Instead of dividing by x plus 2 over 4x plus 3, you can multiply by the inverse to get a single fraction. Like one expression on top, one expression on top.
Yes, instead of dividing, we will flip it and multiply. Yeah, I'm definitely going to do that. That's not the first thing I would do, but I can do it now. It's not the first thing I would do, but I can do it now. Does anybody have a different idea of what you would do first? I'm still going to do what he said, but does anybody have a different idea? Gracie.
I would factor first.
Yeah, if you see something that looks like that, it should scream, factor me. So go ahead and start factoring. If you want to factor it before you flipped it or after you flipped it, it doesn't really matter. So I have it factored. Jacob, how's your day?
Good.
Do you know what I would need to do here? Okay. Watch how I do it. You're going to love this. You ready? I'm going to multiply straight across. All right, I did it. Sanjay, you want to say something?
You can get rid of the x minus 3 and the x plus 2.
What do you mean by get rid of?
You can cancel them.
They'll cancel because we are multiplying and dividing by the x minus 3, so they undo each other. The x plus 2s, they undo each other. Anything else?
You simplify
The x cubes. Yep. And what were you saying, Brandon?
You simplify
Down to 2 because the 4 divided by 2. Okay. So are these two expressions completely the same expression? Here. What I want you to do now is pull your graphing calculator back out. And I want you to go to y equals. I'll put up there what mine looks like. Okay. I want you to do y equals, and on the calculator, let's see if I can hold it up here. Remember I told you I had other stuff in there was this problem because I didn't want to have to retype it in. So what I did was I typed in the original question, and that's another reason why I went over that fraction thing for you. Typed in the original question, and then for y2, I typed in 2. You guys can delete out the other thing you have in there. You don't need it for more classes. I have, you guys were my second class, plus I've got other pre-calc classes, so I didn't want to retype it every time. But go ahead and put those first two question and put, you do not need to graph them. We're going to do something different with it. But go ahead and put those in. I don't know if you'll really be able to use Desmos to check this. So you're just going to have to hang out. And it'll take a moment. If you have those 83s and you need any help with the parentheses, so let me know. But really you just need parentheses around numerators and denominators. So I would just put 4 sets of parentheses in. Once you have it typed in, we're going to go to the table, which is second. Once you have it typed in, we're going to go to the table. Here, second graph. So you guys don't need to see my screen because the equations are on your paper. And when you go to the original expression and our simplified expression, are they exactly equal to each other? Blue and red, are they exactly equal?
Yeah.
Are you looking up here? On yours it is? Oh, yours is not correct. Okay, but mine is not exactly equal. Most of it is. Like if I scroll down, I'd be like, oh yeah, they're exactly the same. But they're not. My first expression has some numbers it absolutely cannot equal. What are those 3 numbers? I'm sorry, I'm like shaking up here. What are those 3 numbers? -2, 0, and 3. So let's go back to our notes. -2, 0, and 3. Oh no. I'll pause the video just for a second because my thing stopped working again. Okay. So what I just, is it -2, 0, and 3? Is that what the numbers were? Okay. So that's something that they do not equal each other on. So what we do is when we simplify an expression, we need to make sure our simplified version is exactly the same as our original version. So after we have that 2, then we put a comma and we write that x cannot equal -2, 0, and 3, so that they are now completely the same. How do we get that algebraically, not graphic, or not using the graphing calculator? How do we get it without the calculator? How do we get it on our own? Ava? Kind of. It's kind of the stuff that I canceled out, but yes. Say it again.
Like if it's like x minus, x minus 3 equals 0, instead of x equals 3.
Right here, x could not equal +3 because 3 minus, so that was in the denominator, right? And what about over here? What if x was -2? It would make the denominator. But what about 0? Why is 0 in there? Oh, right over here. There it is. Yeah, because right here, x could not equal 0. It doesn't matter if you use the first version or the second version. If we have anything, oh, sorry, the first version up here, that's what I meant, or the second version down here. Those are both the second version. If we have anything in the denominator that could make it equal 0, that is already a domain restriction, and if the ending result doesn't have that same domain restriction, you need to tell people that it's a restriction. So now somebody asked me in my last class, well, what if the original question had a few more x's and maybe there was like a 4 down here, and by the time we were done we got 2 over x. How does that affect this 0? We don't need to write it at that point. Because if I can look right here and say, I already know x can't equal 0, that's not something I have to say. Because that's the same in the end result as it is in the original result. I only have to put things that disappear that were in the denominator at some point. Okay? All right. Okay, and then the next example is writing a formula as a function of another given formula. So we're going to write the volume V of a sphere as a function of the surface area S of the sphere. So I went ahead and I looked up those formulas. If you had to do this and you didn't know the formula for a volume of a sphere, you would just have to look it up. If it's on a quiz or a test and it's something that you shouldn't have to know, then I would give it to you. Do you think I'm going to give you the area of a triangle? But the volume of a sphere, I don't think you probably remembered that. So what we're going to do is we have to write the volume so that we have an S as a variable. That's what it's saying. It's saying write the volume of a sphere as a function of the surface area. So that's saying kind of like V of S, where, normally we would say f of x, where the x's were the variables in the equation. So what I have to do is I have to use substitution. Like with systems, I have to use substitution. If I look over here at my surface area formula, what does it have in common with the volume? Let me change what I said slightly. What variable does it have in common? R. Okay, it has pi, but that's not a variable. It has a 4, but that's not a variable. So the variable in common is R. So what we're going to do is we're going to solve. Let's try that again. We're going to solve the surface area for R. We're going to start there. We're going to solve it for R. So surface area, what am I going to do besides to solve it for R? Anybody know? Eden, do you know? Divide by 4 pi. Still not solved for r. Abigail, do you know? Square root? If I square root, do I need to do a plus minus? Do I need a plus minus? I couldn't really tell what you guys said there. Jacob said no. Why? Well, it won't be surface area, but you're on the right track. What can't be negative? Any measurement, but what am I like scribbling under here? The radius. So just like we're finding what the radius equals, the radius can't be a negative number. So yes, we should always think about that plus minus, but no, we don't need it for this one. So we'll just use the positive version. Okay, so now I have r equals, and you know what, guys? I'm not even going to simplify anything yet because we still have to plug it in, and maybe something will simplify, or I'll have to double simplify. I don't want to have to do more work. So now let's substitute. So we've got our volume equals 4/3 pi multiplied by our radius to the third power. So our radius is now square root s over 4 pi to the third power. And we're going to simplify that. So 4/3 pi. Let's see. There's different ways you could simplify the cubed. You can put the cubed inside of the square root if you want. That's what I'm choosing to do right now. There's different ways you could simplify it though. You guys know what 4 cubed is? 64, right? Is 64 a perfect square? Yeah. So when I simplify that next, I'm going to get 4/3 pi. After simplifying the square root of s cubed, that's going to be s square root s. On the bottom, it will be 8, and then pi square root pi. So when I simplify those, the variable and the pi. I'm going to multiply, and those pi's that are outside of the radical will cancel. The 4 and the 8 will reduce. So we get s square root s over 6 square root pi. Did I make any mistakes? Do I have everything? Does that look okay? So in order to rationalize this, we would need to multiply the top and the bottom by square root of pi. So s square root s pi over 6 pi. Oops. V equals. So that's how you will write a formula in terms of another formula. And don't worry, I didn't give you anything that complicated. It's better to do the hard ones with the teacher and then know what you're doing right. The ones in the book aren't that bad. All right, and then we have one more example, and we're just going to go ahead and do that last example. It's from section 1.4. There's a different thing to open. If you haven't opened it yet, I got to open mine still. I'll pause that if somebody's still copying that down, though. Is it hot in here? No? Yes? You guys dying? I'm dying. I'm dying.
Well, it is like 96 degrees outside.
I know. It's like humid. That you should feel the air conditioning? Is that what she's saying?
I feel it.
You feel the air conditioning or you feel the breeze because my windows are open?
Oh, it's probably your breeze.
Yeah. I'm dying. She must be dying too. Cumberledge! Are you saying the air conditioning? You saying something about the air
No,
conditioning?
we were talking
Oh.
about the citizenships test and how my kids are not citizens right now because they
Aw.
can't pass
Yeah.
it. So,
Well, I'm just dying. I was just talking about how hot I am. They say it feels nice, but I'm
there's
dying.
like a breeze right here.
Yeah, because that's why I have my windows open,
But
just
are
so I
they
get the breeze.
talking?
No, I
As
am.
part of when I talk, I sweat because this is making me hot.
I mean, I
Are
take
we
it.
being too loud out here?
No, I take it off when I'm recording
Oh, yeah.
because otherwise, you know.
No, they're just trying to become citizens and it's not working out.
All right, let's see. Is it this one? Yes. All right, you got it?
Yeah.
Are we good? Everybody have their 1-4 notes open? Oh, was I recording? Oh, no, I wasn't recording. Okay. All right, so this is just finding zeros of a function. Just to review, finding zeros of a function would be if I have a function what value can I put into x that will make f of x turn to 0? So what value, that's what we're finding. That is what a 0 is. The 0 is a single value. Now, a lot of people get confused because we start talking about zeros or we're talking about like x-intercepts. And they are related. But you write an x-intercept like x comma 0. You write a 0 like whatever number it is. Like, you write a 0 as just the answer. Okay, so we write them different ways. Again, the zeros are related to the x-intercepts, but they're called zeros because they're saying, what can I input for x to get out 0? So the very first question, f equals 4x cubed minus 24x squared minus x plus 6. To find the zeros, I'm going to just go ahead and say, well, if this was 0 over here, what would make that happen? Do you remember anything about how to solve equations like this, Christopher? What do you remember? You said factor out? Yeah. So you know what you're talking about. You just might not remember what it's called. It's called factoring by grouping them. We're going to look for groups that we can factor, and you're using the greatest common factor factoring. So yeah, let's look at these two being a group, and let's factor out the x squared. And when we factor out that x squared, not x squared, what should I factor out? 4x squared. And when we factor out that 4x squared, I'm left with x minus 6. So then we try to manipulate the second part of this so we can factor something out and also have an x minus 6 left over. So what could I factor out of that second group? Right, so just so you know, right now it's a subtraction. In order to group these separately, I would want to write it as plus a negative x, because once I put those parentheses in, technically there's still something in between those parentheses. It's not multiplication. There is an addition sign in between those. And then what you said, take out that negative 1. That is correct. And when I factor out that negative 1, it changes that sign in the middle to minus again, and we have x minus 6. So at this point, we have a binomial, a two-term question. And we factor binomials by looking for a greatest common factor first. There is a greatest common factor. That greatest common factor is x minus 6. So I'm going to factor out that x minus 6 from both of the terms that I underlined. What is left over when I factor out the x minus 6? Right, 4x squared, subtract 1. Now we are finding the zeros. It does not say we have to find them by factoring. However, factoring's easy if you know how to do it. Can I factor it further? The answer is yes, but you don't have to solve it. I'm going to, just to review that factoring, but you don't have to factor the blue one to solve it. So I will have x minus 6 still, and then this is a difference of squares, so 2x minus 1 and 2x plus 1. Once you have it all factored, we set each factor equal to 0. And we solve for each separate x. This assignment you will be entering in Canvas, so I will give you x equals, and then I'll give you a fancy bracket. You will need to put the numbers in the correct order. So if you don't remember what I've said before, we're going to go from least to greatest. If this was graphed and these were x-intercepts, it would go from left to right. What would be the first number I put? Negative a half. Then a half. Oops, I wrote a negative again, sorry. Then a half. And then the 6. And you don't need to worry about the fancy brackets part, like I'll give you that part. You just really have to put the numbers in the right order. Okay? If I were writing it by hand, I would have written, oh, I'm getting into the other space, hold on. If I were writing it by hand and somebody was just grading what I had on paper, I would probably write this. But Canvas won't check that, so we don't have a plus minus. So. Okay? That's the way you'd have to type it in. All right, let's try that other one. Just last example. We're doing zeros. So let's set it equal to 0. We're going to solve for x. Marie, can you tell me something that I could do? Yeah, factor out that x squared. Okay. And then how about Vivian? Do you know what to do next? Well, does x squared minus 12 factor further? Our rules for binomials, while she's thinking, our rules for binomials would be, first of all, look for a GCF. X squared minus 12 doesn't have one. Second rule, we look to see if it's a difference of squares or if it's a sum or difference of cubes. So we look, and there's a squared, so I know it's not cubes. Is it a difference of perfect squares, Vivian? No. So that can't be factored further. So it must be done factoring. So how do I solve it? Lauren, how do I solve it? Yeah. Because once I set x squared equal to 0 and x squared minus 12 equals 0, I can solve this one by square root method instead. Madeline, can you help me solve this one by square root method? Then square root and get positive and negative. You're ahead of me, okay? Perfect. And she remembered to simplify, so that's good. That's one reason why I gave you this one, something that we just have to remember to simplify. What about x squared equals 0? What do I do with that? Just x is 0. They're both 0, right? So to write that on Canvas, I will give you the x equals, I will give you the fancy bracket. What would we write first? The -2 square root 3, and yes, you got to write out that stupid SQRT. Sorry. And then what? And then 0, and then the 2 SQRT 3. Okay. So our assignment, we've got 2 smaller assignments. They're both in the book. The page for the book, which is right here where it says book link, it's the same link for both of them because it's section 1.3 and 1.4. So same for both of them. I have the answer keys in class. So during class, I would encourage you to either come up and ask, or if I have like a lot of people I'm helping, I'll just like lay the answer key out and then you can just kind of check it. But then I will post the answers for the first one. The second one, you will be entering in, but that second one's like what we were just doing, where you have to enter like the zeros. So it won't be too hard to enter it in. It says coming soon. I must not be done with it yet, but I'll check. But it will be up there real soon. And then on Friday we have a quiz on 1, 2, 1, 3, 1, 1, 1, 2, 1, 2, 1, 1 to 1, 4. Everything we've done up till today, up till now. And if you need extra practice, you can go back and redo some questions, or you can go, if like we did the evens, try some of the odds. You know, all of the answers are on the internet. I know you can find them all. Unless they were a worksheet, I already know they're out there. So I don't feel like I need to give you all the answer keys. You don't know where to find all these answers? Somebody tell him. They're everywhere. But anyway, make sure you are ready for our first quiz. Okay? All right.